Yeah. Okay. Hi, everyone. Welcome. Thanks for coming to this session. I did a similar session to this one about 2 years ago, about every issue I'd ever run into trying to get vSphere with Tanzu to work. That session didn't go over well with VMware marketing, but this session is a little bit more kind, but it's still like stuff like, oh, watch out for this, and just know stuff. So the missing manual, but it's not really a fair title because there's too much to cover, right? It's 24 minutes and 20 seconds, so you're going to get highlights. But I'd be happy to talk to anyone and talk about any aspect of this, and there are some guys here from Evola who would be very happy to talk the same thing with you. So this was so sweet. So this is Katarina Brookfield. She is one of the main technical marketing managers for the VCF division. She's all about Supervisor. She tweeted this a few days ago saying, we're sorry, we changed the name again. So at least there's an apology this time, right? The previous, I don't know, 10 times there was no apology. It was just like, here's the new branding. Yeah, so whoever did something with Vic? Ah. And who's heard of Photon Platform? Not OS, Photon Platform. Yeah, this is old school stuff. Anyway, vSphere Supervisor, or just the service inside the supervisor that makes the clusters, we'll just say VKS, and that's great. It's short. It's VKS. It rolls off the tongue. The AVI is back to being called the AVI, by the way, just so you know. So a little bit more detail here, because of course if that renames, everything else renames, and they're still working on this. There's more to be renamed, of course. You go into the supervisor, there's a bunch of Kubernetes resources, they all have the word Tanzu in it. It all has to go. There's a big project inside that I don't know about that they're doing that. So. Tanzu Kubernetes service, the thing, Supervisor does a bunch of things, right? But one of the things it does, it makes clusters. We call that VKS. It also runs, you can just feed it YAML to make a VM, the VM service. And you can even run pods directly on ESX, kind of, which we still call vSphere pods, but no one uses that, so don't worry about it. Yeah, Supervisor. Yeah, oh, okay, yeah. This is the slide that went with the sentence I just said, because it does more than just clusters. But for most purposes, we'll just be doing clusters, right? So there's different ways to deploy this. And it's getting more flexible. That also makes it a bit more complicated. So VM service, vSphere pods. This is the thing we're focusing on. Single cluster, and with a cluster, I mean an ESX cluster in this case, right? Zonal came next, where you could spread it out over 3 data centers. Who here has 3 data centers? Yeah. Who has 2 data centers and doing stretch? And who is just, we have 1 data center? Yeah, okay. So this was a missing piece for a long time. And with U3, they now officially support this, which is nice. There's basically 2 ways you can do the networking around Supervisor. You either say, I'll just do DV switch, and with DV switch, you can also say, actually I shouldn't say segments there. With DV switch, I can say, that can be segments, right? So, but it's flat networking. Or you can integrate all the networking with NSX-T, and then things get a lot more complicated, but also more powerful. So if you have NSX-T, if you have VCF, you have NSX-T, you have a choice here. Right? This is simpler to troubleshoot. This is more capable, but more complicated. And you'll get all these slides, by the way, so don't worry if you can't take pictures of everything. I encourage pictures, though, because it's, you can tweet them. vSphere zones. This was introduced a while ago already, but it took some time for this to really flesh out when using it in combination with Kubernetes. vSphere zones allows us to say to vSphere, hey, the stuff that you're deploying exists in multiple sites. And this is important because we need to know that inside Kubernetes in order to align how we deploy workloads inside of it. So right now, this was introduced firstly to support that three-way zonal deployment. They've now introduced stretch cluster support, so that's 2 availability zones, right, 2 DCs. But this doesn't quite work together yet. But it will. So this is the utopia, because who can afford this? No one has this, but this is the assumption that a lot of cloud-native developers, workloads, companies think of. They think, I can deploy to Amazon or, or Azure, and I can have as many availability zones as I want. In our reality, we usually don't have 3, but if you have 3, you can do this. You can spread everything nice and evenly, and this is the best match to cloud-native thinking. So this is what that looks like when you do it with Supervisor. It's still got the old naming in here, because old screenshots. But it spreads out a cluster. Every cluster you make, it spreads it out across those 3 sites. And that's cool, because then inside Kubernetes, you can pick and choose which bits go where. But that requires talking with your developers, or making them at least aware that you have this zonal infrastructure. That's why the vSphere zones exist. You have to tag things inside. So inside the cluster, you can see, oh, this is one availability zone, that's the other. And then you can match the application architecture to make use of this. It's very powerful, but it requires 3 distinct things. And this also requires, I think still requires NSX-T right now. Or doesn't it? Requires, oh, sorry, no, VLANs as well. You can use either, yeah. Yeah. So, the animation is a bit weird. So, what if we have a stretched cluster, right? 2 data centers, that's what many people in Europe have. What do? Well, we all know this bit. Okay, if I take a Kubernetes cluster, I can maybe do this, but then, do I place it all on one side? Do I take the control plane and do I kind of spread the control plane across the data centers? The answer is no, because this is a 3-way quorum system, and you can't divide that by 2. That makes no sense. So so Kubernetes itself, and that includes the supervisor itself, by the way, and anything that goes into a Kubernetes cluster that has this kind of mechanism inside, etcd is the Kubernetes example, but lots of data services work the same way, right? Active-passive replica with a witness, or so a lot of things work this 3-way thing. Don't try and stretch these over the 2, right? Because those mechanisms, cloud-native mechanisms, are meant to work in pairs of 3. So you don't do that. What you can do, so HA, and you pin these, right? And there's another slide that shows a bit more detail. But you can do this. You can have you can do active-active for workloads as long as they're not like that. Anything that's like a single container, you can choose, I'll run it there or run it there. So it's not like you can't use that side, but control plane, Kubernetes control plane, application control planes, data services that work this way, pin them. The rest you can play around. But always be aware of the application architecture. We're not used to being aware of that as VM admins, right? But here you have to be aware of the application architecture. We'll do questions at the end, if that's okay. So this is the official slide from VMware. This is in the docs. These are some of the rules. There are specific requirements. Obviously, a lot of them involve around DRS rules, right? And right now, those DRS rules, the DRS groups don't maintain. So if you upgrade this, you have to make the DRS rules again. Which sucks. I hope they fix that. Yeah. So wait a minute, what about storage? Because if we're doing a vSphere stretch cluster, we also have active-active storage replication, right? That's the only way to do vSphere stretch cluster. So what about the 3-way? What happens to our storage there? Unfortunately, there's nothing in there that does that. You have to bring your own solution, and there aren't that many. there's some open source projects, and then Portworx is very good, and this, the Pure guys are over there, if you want to talk to them. They can solve for this really nicely, but it's not cheap. But if you do three-way, if you want to make that cloud-native availability model for the app, you have to then also do something about the storage. Or you can say, well, the application owners or the developers need to deal with state. That's nice in theory. In reality, many developers are not there yet, and they probably never will be. So we're going to have to solve this, as usual. But this is kind of what you'd want, right, at that level. If you want more details on this problem, come to my session tomorrow morning, because I spend 45 minutes talking about just this problem, because it's a big problem. Okay, supervisor services. This is a kind of a weird one for me. So supervisor services are add-ons to the supervisor that allow you to do more stuff with supervisor, usually the Kubernetes part of it. Supervisor services are, the supervisor control plane is just another Kubernetes cluster that it takes your ESX cluster, it turns it into a Kubernetes cluster, and then it adds a bunch of stuff to it that makes you do, you can do the VM service, you can do vSphere pods, you can create clusters, and you can add stuff into the same place, the same control plane cluster, the supervisor cluster, and it makes it do more stuff. The problem with this has been that these features have not been maintained very well the last few years. Now, I'm seeing a change as there's a new focus inside the VCF division after the acquisition. They're starting to work on this again. But some of these supervisor services are a little bit out of date. Be very careful if you go down this route. And right now, up until, I'll still say today, I tend to avoid these, to be honest. Because what they do, I can usually do it by doing an open source project inside Kubernetes and running and controlling the whole thing myself. But that is changing slowly, right? So I think this will be a lot more mature again in about a year's time. So watch this space. One of the signs that this is a maturing space is that updating some of this stuff, working with these services, is not flawless right now. The control plane itself, the thing that makes Kubernetes clusters, is actually also a supervisor service. They call this a core service. And you can upgrade it independently, just like you can any other supervisor service. Now, that wasn't the case before U3. You had to upgrade vCenter to upgrade all of that functionality. Now it's separate, right? So they can also support Kubernetes versions a bit more faster now, for example, right? But this is a bit buggy. Be very careful around this. It's very new, so that's basically the message. It's new, pay attention, don't believe every health check when it's green. If you want more details, the Evola guys have extensive experience with dealing with this already. Yeah, basically this. This is all the current supervisor services, and a bunch of new ones have started making an appearance. And this one's like really new. Argo CD, you just have Argo CD in the supervisor cluster, and I can now do GitOps, right? Yeah, part of the problem here is this is not, you won't find any of this in vSphere docs. It's all, the whole documentation is kind of there. Think of these as flings, mostly. That's kind of the quality level. And these top ones, well, since the acquisition, let's just say I don't think anything's going to happen with those. Don't use those. So what do you use then? Well, for Registry and for S3, and for backing up with Valero, I tend to say do it outside. There are advantages, especially for S3 and Harbor, the registry, to just run them on a VM. The main advantage being I can just back it up. And everything that's probably worth a value around this stuff is going to end up in the registry. And if I do need to back up persistent volumes, I can always just run Valero myself in a cluster, and probably a way higher version than the one that supervisor services offer. But it is improving. The supervisor services do give you a nice little UI that single click to back up a cluster with Valero, theoretically. I mean, does it actually work? Okay. Yeah, maybe do this for yourself for now. We'll see what happens in a year's time. Carvel packages, this is also a kind of a weird one. This in the documentation you'll find that, oh, I can add stuff into a cluster, not the supervisor this time, but into an actual cluster using Carvel. And VMware will support you on those open source projects. So you can raise a GSS ticket against any of these, as long as it's the Carvel deployment. But this is also an area that's kind of lost focus, shall we say, within the VCF division a little bit. So I tend to also ignore these. I just go open source, community editions, Helm charts, just base what you're putting in these clusters on something you control a little bit better, that's a little bit more standard. Carvel's very powerful. I'm a fan of that toolset, actually, but it's a little bit niche, and you won't find a lot of documentation about it. So maybe just go community versions for all this stuff. But the advantage is, if you really do like support, consider it. But look carefully at a case-by-case basis where VMware support would be beneficial here, right? Broadcom support. Right, networking. Oh, sorry. Nice. Pictures are nice, of course. And it gives me a chance to sip some water. Arguably, this is the hardest part of this. Especially the load balancer situation is always a little bit tricky. I can't go into a lot of detail. Just to recap, we need a load balancer, just to start with that. So if you're not familiar with VKS or Supervisor or Kubernetes in general, you always need an external load balancer in some way. You need it for the Kubernetes API, and you need it for workloads. In VKS, you have to use their integration with either NSX-T or the AVI, especially for this part, for the control plane. For workloads, you can add whatever integration you want after the fact. By default, it'll use the same load balancer in either case, but if you have an F5 or a Citrix NetScaler or something like that, you can also integrate those and do workload load balancing using those instead of the AVI or NSX-T. Worth considering if you've already invested in a load balancing solution like that. Yeah. So just in more detail, control plane load balancing and workload load balancing. This is only layer 4, doesn't go much further. This is layer 4 and then layer 7, where we say layer 4 for load balancing, and then layer 7 is what we call ingress. But if you're confused by the term ingress, just think reverse proxy and you've basically covered the same concept. But it's just running as a container this time. Those integrations that you get out of the box, HA proxy, the AVI load balancer, and NSX-T. Now, NSX-T is actually a tricky one, or it's a bit of a trick question, because you can do NSX-T with the built-in NSX-T native load balancer, or you can combine the AVI with NSX-T. You need the enterprise license for AVI to do that, and then you end up using AVI in both these cases, in reality. This is not production ready, and never will be, so don't look at that. Oh, it's good for labs. So for about 3 years now, the NSX-T guys have been said, hey, our native load balancer is being deprecated, by the way. They've stopped saying that a little bit. They've said it's deprecated for everyone else except our own stuff, so we'll continue to support it for now. This is, pay close attention to what is going to happen with AVI in combination with VCF or with VVF the next few years, because things will change a little bit. This is all going to change. I don't think NSX-T load balancer will end up being used at all, and I think that integration will go away eventually. Or the other extreme is that the AVI goes away, but I don't think so. So NSX-T deprecated, right? AVI with NSX-T. So here you're using the AVI as a cloud type, or using NSX-T as a cloud type for AVI. So there's a straight integration, but they're still two separate things. You still have to install them separately and lifecycle them separately. And then you can use AVI completely standalone, no integration with NSX-T. That's easiest, but it's also the least functional, because to do this, you require the enterprise license, and then the AVI can do a lot more, like global site load balancing. You can use it as an ingress controller. With the AVI standalone, it does almost nothing except layer 4 for Kubernetes, and that's it. That's all it does. I'll skip this one for now. Be careful in this difference. The free tier for AVI and the enterprise ones is not just a licensing difference. And it's not just like you can now get extra capabilities. The actual behavior of some of the stuff inside suddenly changes. And this is really annoying, because if you want to flip between the two, you find you can't. And even how it routes networks changes, because there's some long-standing routing magic that happens with the AVI, and it's way more powerful at that very low level when it's the enterprise edition, when it's licensed for the enterprise version, than with the free thing you get by default. This really matters because, in one situation you think you have your routing and your firewall rules figured out, and then the next one suddenly you've got asymmetric flows going all over the place, and you're like, what the hell happened? Yes, because the AVI can do a lot of cool stuff, but you need to understand it really well if you're going to use it under the enterprise license. This is not supposed to be an animation. Back, yeah, great. So this is some best practice around networking. Theoretically, you can do Supervisor with one network. The minimum in the docs is 3. I say minimum is 4. Why? Because, and you won't find this in the documentation at all, except in one picture that has not been updated in 4 years. The Supervisor control plane VMs, the Supervisor Kubernetes cluster itself, they're dual-homed. Go check them out. They're actually dual-homed. They have their own little internal load balancer on this side. They don't rely on the AVI for that. And then on this side, that's how they talk to that's how the Supervisor does all the internal talking with the stuff running inside those workload clusters. But they're dual-homed. This is a security issue for some people, because this is like a routing shortcut. No, my router is supposed to be there. My firewall is there. What are you doing? So I tend not to use the primary workload network. I tend to tag it as a secondary management network and not run anything in there, because it doesn't have the same security profile as any other workload network I make after that. Now, another concept you'll see in the documentation is the concept of a shared services cluster. That's your cluster. That's the cluster you use to run stuff like Argo, or Harbor maybe, if you want to run it as a container, which I don't recommend. But this is optional, right? It's just another cluster, so don't be fooled by the name in the documentation. It's overly complicated how they explain it. It's just another cluster. It just happens to be your cluster. And then you've got workload clusters for the users. Now, I won't go into detail here, but this is one of these examples where the AVI does weird stuff which you don't expect, and it's not well documented. The point is this. You really have to understand the AVI really well in order to understand what it's doing in load balancing. Don't assume that if you know NetScaler or F5, which works the same way, it has specific ways it does things. Read up on that in the AVI documentation. You'll need to kind of understand this, otherwise weird stuff is going to hit you and you won't know what's going on. So we have the port list on the VMware site, ports and flows for firewalling rules. That is not sufficient. So people like ITQ and Evola, we make our own lists like this in detail to show how the flows are going. If you want to firewall between all of those different networks and all the components, it's a very, very long list, and some of it's not documented. So if you want the magic keys to the kingdom, you know who to talk to. Sell. Docs are confusing as hell. This is going to be renamed very shortly, according to Katrina. So, but just be aware that the documentation is kind of vague here. The naming of things is very specific to concepts that they have. Like they'll talk about a workload. What they mean with a workload? They mean a VM or they mean a vSphere pod. But they don't mean clusters. That's what they mean with a workload. They don't mean the workload that goes into the clusters. They mean a supervisor workload. Confusing naming, right? That's why I made this slide, to explain what the hell it is they're talking about. You'll get these slides, right? And if you don't, please contact me and I'll just send you the slides. I'm running out of time. Okay, I'm going to skip this part because I also do this tomorrow morning. So now you have a reason to come to my session in room 17 at 9 a.m. for my session, because I cover the same thing. But I'm just going to talk about how to optimize vSphere at very low level to do all of the cool stuff to make your workloads actually work properly. But I'm going to skip that now, sorry. I'm going to end with this. I joined ITQ about 5 years ago. Said I've done everything with NSX-T and vSAN and the whole world, and it's useless to you because all I want to focus on is cloud native. This year, for the first time in 5 years, I'm excited about vSphere again. It's really weird. And this is the reason. They are turning the supervisor into one control plane to do everything. They are going to collapse, probably, futures, they are probably going to collapse as much as they can into the supervisor because it's easier for them too. One way to control the whole thing. All of the new ARIA stuff that uses VMs, it's not using VAPI, it's using the VM operator inside the supervisor to spin the VMs. That's a sign of things to come. Everything will end up inside the supervisor, mark my words. It means one Terraform provider, right? Because you're talking to the Kubernetes API to do everything now. Do you know what this looks like when you've done this? It's OpenShift. And this is an example of some of that cool stuff this enables. This is where they're adding now functionality to make this really user-friendly. And all this has happened in the last 6 months. I'm very impressed with the direction here. So I'm going to leave it at that. That's all I could cover. Thank you very much. I have a QR code for the people going for the things. Thank you very much.